Okay, hello everyone, and welcome to a special edition of Handmade Hero. This is not actually part of the main Handmade Hero in that it has nothing to do with game programming. But what I wanted to show today was I'm going to add, there's a little utility that I have that I've been meaning to release for a long time. I kept forgetting to release it, and I never, I don't ever like actually having to use anything like GitHub or any of these sorts of things. But of course, since there were so many people who asked to have a Handmade Hero GitHub, and we have the one right now that if you pre-order the game, you get on that special GitHub or whatever. Now there is a way to actually have things go up there automatically, since I have a little script that just pushes our changes to it. So I was like, oh, I can finally release this thing. I should do it. So I wanted to give a little brief demo of what it is. It's very, very simple utility, but it's kind of useful, and especially useful for people who maybe are in situations where they work on larger teams and have problems with their build times and stuff like this. So this is a utility called CTime, and you can see here that I've typed it into the command line here, and it printed out its little usage information. And what this utility is designed to do is this utility is designed to give you some perspective on what your build times actually are and how much time you're spending sitting around waiting to have your projects build, if that makes sense. So, typically what ends up happening, if you're somebody like me, you're extremely, extremely careful about your build times, and you make sure that your build times are always very, very small. And so, for example, if I have a build time that's getting to be 10 seconds or something like that, I think that that's probably a really big problem, and I should go look at why the build is taking so long and make sure that it's stays well below 10 seconds. I consider that an emergency. However, there are a lot of places out there which don't seem to have very much respect for how problematic long build times actually are. And they have these turnaround times for doing full rebuilds of things that are in the, not just in the minutes, sometimes in the hours. And I think that is extremely, extremely problematic. And obviously there's lots of people who disagree. And that is some place that I just do not see even remotely eye to eye with those people. If you ever have a build time that goes into a minute long, you've done something horrifically, horrifically wrong. Because you can compile massive code bases. You can compile code bases that are hundreds of thousands of lines, even millions of lines, in much less time than that. So you have to kind of ask yourself, how did you let it get to the point where your build times are taking that long? And why do you not see sort of the really deleterious effects that has? It's something that really stops the flow of programming. It makes it so that testing various things becomes very, very difficult for programmers to do. And even if you've got it so that you can recompile little portions, that's not the same, because there's plenty of changes you might want to make and that affect large numbers of files in your system. And if you've basically put in place this negative reinforcement so that programmers are incentivized to make tiny changes to small parts of the code base, but massively disincentivized to change large parts of the code base, well, you've basically ensured that you will never get improvements that cover large parts of the code base. That's what you did, right? So you have to be very, very, very careful about build times. And I really wish more people were. And so this utility is kind of a thing you can use to help gather information about your builds, make sure that you stay honest about your build timings, and also be able to perhaps use to demonstrate to people that build times are a problem if they don't believe that they are, or at least so that you're not just randomly saying stuff like, well, I think our build takes too long, or stuff like that. So let's see how to use this tool in practice. And what I've done, like I said, is I put it in the Handmade Hero build now. And so if you take a look, when you if you download it from Sendowl, if that's where you normally get it for, or if you go to the GitHub, if that's where you normally get it from, if you already bought a Handmade Hero and have access to it, it's in there already. So you have it. And after the stream, I will push it, and it'll be up there. Well, I guess actually, technically, maybe it's tomorrow that it gets pushed. I don't know. Whenever the next push is, by the end of Monday's stream at least, it'll just be in there, and off it goes. But I also put it, the notice on it puts it in the public domain, so you can also feel free to grab it and put it out at that point. So it's not protected by the Handmade Hero license. It's got a public domain license, and it can just be free for everyone to use. So if you take a look in the Handmade directory, it's in there. There's the CTime directory. It's got a single C file. Source code is all it takes to build it, so you can also modify if you want to. But let's take a look at how to use it. So the way that it works is it's exactly analogous to block profiling for an application, but it's for builds. So what you do is you basically put a begin and end pair around anything that you want to time, and instead of giving it a name like you would in a normal block profiler, you just give it a file. And that file is where it stores the timings, and it will store those timings forever. So as many times as you run that build, it will update that timing file with an entry for having entered. So it's literally, if you've ever used a block profiler, even like the kind we made on Handmade Hero, you already know how this works. It works exactly like that. And I'll show you how we do that here by just adding it to the Handmade Hero build as we go. So let's open up for it, and I'll show you what we have right now for our Handmade Hero build, right? Here is our project. And when I normally build it, right, that's what we see over there. There's the handmade.cpp, creating library, right? That's the build happening. But you'll notice, even right off the bat, there's kind of this annoying thing of like, I don't know how long that build took, right? I mean, I know that Handmade Hero's build process is not a problem. We always make sure, like I said, I'm very diligent about that, I keep it short. But even because we never talked about CTime, normally my builds at work, I always know exactly how long every build takes. But if you look here, I have no idea how long this build takes. And that's a common situation for a lot of people to be in, is they don't really know how long their build even took. They have no idea, right? And sometimes your build, your compiler may have a switch you can turn on that maybe prints it out, but if you have other steps, you don't know, and if you compile multiple things, you might not know how long it takes, right? So there's all these kind of things where you don't necessarily know, depending on the tools you picked or whatever, you may not even know what your total build time is, which is a problem to begin with, right? So CTime at the very least solves that problem, because what you can do is, I'll go ahead and load up the build.bat. Here is our build.batch file. This is what does our build. So what I can do now is I can say, well, okay, I would like to record the timing for this build. So what I'm going to do at the top of it is I'm just going to type CTime begin, and that CTime begin call allows me to basically say I'm starting a timing block, right? Just like a normal timing thing was. Now I need a place to put it, and normally, I have a directory in my build system where I just put all of my timing files. So normally I would have a directory for that, but I'm just going to go ahead and put it in here. You can see normally I believe we run the build from directly out of here. I'm just going to put the timing file in there, and we'll just check them in, and we'll keep them around, because there's no reason not to. They don't get that huge, Maybe they're 100, 200K after 2 years of programming or something like that, but it's not like you really care how big they are. They're not onerous, right? So what I'm going to do is I'm going to say CTime begin, and I'm just going to say like handmade hero .ctm, okay? And that'll just keep our timings in there, and off we go. And then at the very end, when we get down to the very end of the thing, I'm just going to say CTime end, and I'm going to pass it the same file, right? So basically, that's just the begin and the end block for the profiling. And now when I build, right, you can see that I now know exactly how long my build takes, because at the end of that profiling block, it'll tell me how long the build went, and right here, for example, it says 1.327 seconds. So I now at least know, unlike before, how long our build is. Well, our build for Handmade Hero takes 1.3 seconds to occur, and that's something I'm perfectly comfortable with. Like I said, like anything under 2, 3, 4, 5 seconds, I'm okay with that. When it starts to crawl up towards 10, I'm nervous, right? Heaven forfend that thing comes back and says 24 minutes or something like this. That would be real bad, but yeah, that's a separate issue. So anyway, so that's how CTime works, and every time you build, it'll do exactly that. So you can see I can build this multiple times, and it just keeps saying, here's how it is. So first of all, at least if you do nothing else with it, at least you could know how long your build is and always be aware of that, which I find helpful just to begin with. But it has a few more nice features, and I'll go over what those are now. So here we are in this directory, and if I do a directory, you can kind of see, in fact, I guess I'll isolate it for you. There it is. That's the file that we created, the handmadehero.ctm. And obviously, if you want to profile multiple blocks independently, that's pretty easy to do. You can just do CTime, and you can put a separate begin and end pair around any particular parts that you want to time, and then they will be recorded into a file like that. Once you actually have one of those files, you can start to ask questions about it. So for example, if I want to, I can say, well, why don't you tell me some things about that block, right? And what that does is that basically gives you a dump, which says, okay, how many times did you actually get complete timings? And a complete timing is one where the begin and end pair actually executed. So if you have a begin and you never get to the end because maybe the batch file crashed or something like that, that would be an incomplete timing, and those are not counted because they don't know how long they took. So if you have a begin followed by another begin, it will count that first begin as an incomplete timing because you don't want it to, you know, it has no idea what it is. And then it'll give you just the basic statistics: how long was the slowest build, how long was the fastest build, how long was your average build, and how many total seconds did you spend in builds for whatever these were marked. And we'll talk about this successful part in a second, because we haven't quite gotten there yet. And then these are not particularly useful yet because we haven't really recorded more than 1 day's worth. But after you record multiple days worth of timings, it will actually start to fill in these graphs, so you can kind of see over time how your build has been progressing. And in the all, this up here where it says all, these graphs show you how your build has been over the lifetime of the project. And as you know, you can see here, like this will go up. So days between first and last timing is 0 because we haven't had multiple days. As that gets longer, it'll say like, oh, 200 days have elapsed between the first build and the last build recorded by hand, recorded by CTime or something like that, right? It also gives you this recent one, which is just 1 day per bucket here, and that's the last 30 days, right? So you can kind of see how your builds have been going recently, and how many, you know, this is how many there were each day, and this is how long each one was taking, and this is the average times here. No, sorry, this is the worst times here, is what's recorded in these buckets, right? Finally, at the end is probably the most interesting number that you care about, which is how long have you been waiting for your builds. And so, for example, I've been running CTime on our current project at Molly Rocket, and the base build for that project has been a total of 2 hours spent building it over the course of the past year and a half. So that's just an example of like how much programmer time did you actually lose over the course of a year and a half or whatever, waiting for builds because they couldn't test something and had to do something like try to pipeline other changes with it, right? Like how much was it actually impacting their ability to test changes? Now you know, right? So that's a pretty interesting number. The other thing that you can do with it is you can say, well, I would like to get this out into some kind of a graph that I can use, or maybe run it through an analysis tool, or create a presentation based on it. And so what you can do is you can pass minus CSV to it, and what it'll do is it'll give you a little thing here which you can actually use. That's just a comma separated list of stuff. So you can import this into something like Excel, and you can find out, you know, more information about it, or maybe you can import it to something like Tableau, like some kind of data analysis tool, which allows you to create graphs or investigate the data. If you're someone working in a large company and you want more information on this, maybe you collect a bunch of these and you want to pull them all into something and look at different programmers' timing files versus each other, or I don't know what you want to do, but you could do that. And obviously you can also concatenate these together if you want to run multiple ones together and run through something. You could do that as well. I should probably include an option to not have any headers on them, but I haven't done that yet. It's pretty trivial, obviously. If you wanted to, you could just take the C file and get rid of it, right? So the other thing you could do in here is, if you remember, if I go back to the stats, if you take a look at what happens here, it'll say timing's marked successful, and you'll notice that's all it says. It doesn't say anything else. Well, this successful part is based on when you call CTime end, what it will do if you would like it to. You know, obviously one thing that I can do if I wanted to record different sets of timings for different types of builds is this CTime begin could include here like something like % like build name or something, right? So I can have different sets of timings for different build names, and that would work just fine. But what doesn't work so fine is if I wanted to have different sets of timings for whether or not the builds succeeded. Because obviously a build that like ends early because of an error is a different sort of beast than ones that go to completion, because it may be timing less stuff, right? And when you call begin, you don't know whether this build will succeed or not, so it's not like you can create a separate timing file for it. And so what CTime does is it allows you to actually pass an additional parameter at the end when you finish the block that says, did this block actually run to completion or did it fail somewhere in between? And the way that you can do that, and I actually document that inside the CTime file, so you can actually see it. Here is that, oops. Here's the CTime file right here. What you can see here, this is what I recommend, is basically in the DOS batch file or whatever you're using. When you do your build, you can figure out whether there was an error or not, right? And I don't know to what extent we do that here. We don't compile the simple preprocessor anymore, and we don't compile the asset builder. So all we really do is this right here, where we do this build and then this build after it. And so, you know, what I might want to do is just say, well, let's not count the Win32 successor failure, maybe. You know, I don't, again, it's hard to say whether we'd want to time those as two different blocks or how we'd want to do it. This is all up to you. It's exactly analogous to profiling a program. You have to kind of decide what you're trying to gather statistics about. But let's say that once we do our build here for the majority of the code on Handmade Hero, I want to capture whether or not that actually worked. Okay, so I'm going to capture the error level that came back from CL. And then what I'm going to do is I'm just going to pass that to here, so that if the build failed, it will be known that this was a failed build versus a succeeding build. So now I build it here, and I'm passing that to CTime. And so when I say, hey, I want those stats, you can see that I don't actually get any yet because it succeeded. But if I was to go into handmade.c and break the build intentionally, which I can do here, like by inserting an error, for example, and now I build, well, now there's an error. And if I look to CTime now, you will see that one of them was marked failed. And you can see that the failed build is quite a bit slower than the successful build. So this will keep those two timings segregated. And like I said, that's necessary because there is no other way for you to have fixed that. Because you need to give it some file where you can store this information. And that's just an unfortunate reality of batch files, I suppose. Maybe I could run a little service or something. But I wanted to keep this a very simple, easy to port utility that anyone could move to another platform if they wanted it for like their Linux builds or their Mac builds or something like that. I didn't want to start having services and named pipes and all these other sorts of things. I figured you wanted to have a file. And so in that situation, obviously, you need some way of having the file include more than just that information, and that's what it does currently. Eventually, I could see extrapolating that more to timing different parts and keeping them all separated in the file, but it just hasn't been much of a priority because most of the time, really what you just care about is how long did the total build take? That's it. And so it hasn't really been worth it to try and put in other things, and so I never did. And so now if I go back to this and it succeeds, then again, you can see when I come up here, it tells me that information, 5 and 1, right? And so here's the total time we spent so far. As you can see, it continues to go up. And so this is that number that you mostly care about. Again, if I go back and take a look at CTime.c, you can also see in here that if it's something that you would like to, this is the public domain notice. Like I said, you don't have to, like this can be freely disseminated now once it's out there. Yeah, that can be freely disseminated and modified however you want to use it in your products and that sort of stuff. What you can kind of see if you take a look at this here is it's a very, very simple program. There's really not much to it. I don't know how many lines there are, but 738 lines, I guess. It's very, very straightforward. It relies on almost nothing but the C runtime library. However, unfortunately, and I don't know if this is something that really can be fixed, because I don't know if anyone ever really updated the C runtime library much to fix it. Unfortunately, there is a little bit of basically platform required stuff here. So you can see in here that it includes Windows.h, and then it's got 4 functions, right? 5 functions. That's because I don't know of any way to get high resolution timing information out of the C runtime library. So at the moment, that's why that's the case. And it's set up to basically allow you to port, because all you have to do is port these 5 functions, which should be relatively easy to do to the operating system of your choice. However, that is the current holdup due to as to why you couldn't just compile it directly without doing any porting on a platform other than Windows. If somebody does happen to know, I don't keep up to date, like I don't even use the C runtime library in my projects at work, as I've mentioned before, so I don't keep up to date with it at all. But if someone who's more up to date wants to port it to the C runtime library, if they do have high resolution timing information now, where I can say, at the start of a batch file and the end of a batch file, I can get really accurate times, millisecond times of when we started and ended, then that would be cool to add, obviously, so that this would no longer depend on any platform-specific stuff. But at the moment, I don't really know of a way to do that without going through the operating system-specific piece of information. But that's the only thing you really need to worry about if you wanted to port, so you could do that. And again, if you do want me to reincorporate other ports, if you do one for Unix or something, let me know, and I'll try to merge it in here at some point. So that's about it. There's not, like I said, not too much to it. It's pretty straightforward. It should be really easy to understand if you want to go in here and modify anything. Yeah, and that's just about it. I feel like probably one thing that I should do and never really did is I think currently, because my builds are always a couple seconds, I didn't actually add something that if the build took, say, an hour and 45 minutes, it doesn't actually print it out as such. It would still print it out as a number of seconds. And you can kind of see what I mean by that. You can see that, where is it here? Here is -end. So you can see when it goes to do this right here, it prints out this CTime and it says what the seconds were, right? And there's actually a function in here called print time that will take seconds and turn it into something, take milliseconds and turn it into something useful printout-wise. So I feel like that's probably something that I should do. Maybe I should have done it before I printed it, but like I said, I don't ever run builds that take that long, but now this is out in the wild, people might be running builds that take like an hour, and it's going to print out the number of seconds, which is going to be not probably what you wanted. So maybe that's something that I should fix. I suppose I could fix it right here on stream. It wouldn't be particularly hard. So the way that would work, there's a function in here just called print time, and I guess I'll go to it so you guys can see what I'm talking about. So if I jump back up here, you can see, where is it, print time? You can see it's a pretty stupid function. Where are you? Right here. It's really, really dumb. But it can handle, even builds that took a week, it would tell you that. And so you can kind of go in here and leverage that code. So if I just take this out and put that in here, like so, we should be able to get something that prints out the milliseconds and something that you could use even if your build is really, 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 really horrifically bad. So if I was to do that, I could get rid of this here. And just put that as the preamble, essentially, and then come in through here, rearrange this so that I call this separately. So here's my my standard out. Let's go ahead and fix that there. And so here's that CTime call. Here's the %s. I don't need to pass this anymore. It's just going to be whatever the timing file name is. And that should basically give me something that prints it out in a way that's going to be friendlier for people whose builds take a long time. So let me go ahead and rebuild that here. Let's go into CTime. If you want to rebuild CTime, it's very, very simple. Here's the build.bat. As you can see, there's almost nothing to it. The only thing it needs to link with is the WinMM, and that's because it tries to use the high-resolution timer, like I said. So if you hit build, it should be straightforward. It shouldn't really have any problems. There shouldn't be a lot of errors or warnings or anything like that. And what comes out of it here is that CTime executable. If I copy that CTime executable over to our MIST directory where we keep our batch files, I should now be using the new CTime. And so if we were to now build Handmade Hero again, we should see it print out the new style, which is 1.7 seconds instead of S, and there you can see that's the case. I probably should include a space after that there. But that's about it. So let me try that one more time. Build and copy. And there we go. So now that will also print out in a little bit nicer fashion. It'll do, oh, your build took 2 hours, 45 minutes, whatever. Heaven help you if it days ever shows up in there. But that's about it. So that is CTime. Like I said, really simple utility, but it's one that I find it's a lot of fun. It's so easy to add to your build. If you wanted to, you could probably even do it if you're one of those people, and heaven help you, but if you're one of those people who actually tries to build from within Visual Studio, you should be able to use one of those custom build steps. So I've never tried it myself because honestly, I would probably rather I'd probably rather program with the standard template library than I would want to have to build my project with this thing. But if you are in this environment and make your build using the Solution Explorer, you can probably add it as a custom build step, I would assume. I don't actually know, because like I said, that's not something I ever do, but presumably in here, if you were to look inside the project properties, usually there's a way to figure out in here how to add sort of special things. And so I don't know, like, maybe, and please take this with a big grain of salt, because I don't really know what the right places to do it. But here's custom build step, and I suspect you could probably put it in here. Here's build events. I suspect you could probably put it in here, but I have no idea. So take a look at your documentation or try to figure that out if you're interested in it. But I suspect you could probably get it to slot in here reasonably. And so if you don't happen to use some kind of a build that executes in the shell, that shouldn't preclude you from still keeping track of your build times if that's something that you are interested in doing. So that's about it. I will briefly take Q&A, but I'm assuming that there really aren't any questions and answers, because I wouldn't imagine that this is particularly confusing, but I will take a quick Q&A if there's anyone who has any questions about this that I maybe forgot to cover. Frosty Ninja, time the CTime build. All right, that's just going too far. Let's see. Insofar says libc has clock. Is that not good enough for timing? What's the resolution on it? Let's see. C runtime library. Let's see. Is the number saying? So I think, I could be wrong, but I believe I tried this and the answer was no. That at least on Windows, at least with that version of the compiler or whatever, the clocks per second was not high enough to be a useful timer. But I could be wrong about that. What is clocks per second? Do we know? We already looked at that. I don't know. So I guess what I would say is, I don't remember. It may have been that I only tried time, and maybe time was the one that wasn't good enough, and maybe clock would be. So I don't know. I guess what I'd say is the source code's out there, so if anyone wants to play around and see if they can get something, I would like it to be, at least 10 millisecond granular or better. Preferably it'd be millisecond granular. It doesn't have to be more than that, because these are builds, so it's not, it doesn't need to be any more than that. So, insofar as POSIX mandates clocks per second is 10, what is that? Is a million. So that would be fine, if that's actually the case. Well, so I suppose there is one other thing. So I suppose, yeah, but this could probably be fixed as well, I'm guessing. Yeah, I'd have to look at it. Like, you can see that sort of the way that this works, right, is that when it does it uses the date stuff too. So, but that could probably be ported as well. So yeah, if it's guaranteed to be a million clocks, then that should be fine. And this could be replaced with that, and it wouldn't need time get time. So I'm guessing that that would be fine. Oh, and Furlough Choice says that it's 1,000 clocks per second. Well, but that's still 1 millisecond granular, so that would still be enough. That would still be enough. Like I said, so I would be fine with porting to that, right? It doesn't need to be more than a millisecond granular, certainly. It's just timing a build, and so it doesn't have to be... It needs, I would like it more than a second. I would like to be higher resolution than 1 second, but, you know... Miblo, cool stuff. If we port it to Linux, would you be cool with us packaging it up for the Arch user repository and then hopefully have it promoted to the official community repo? Yeah, you can do whatever. It's public domain now, man. Do whatever you want with it. Elvin, I tried the custom build stuff in Visual Studio before. It's terrible. Yes, I don't ever try to build anything in Visual Studio because it's awful. But if you're somebody who does, presumably then you're okay with it. And I think you can put other things in there because I remember back the last time I worked on a project where I had to use Visual Studio, you could put things in there. So it does have custom build steps. Yes, it's janky, but it does work. Sean McGrath, is there a CTime time to calculate how much CTime adds per build and by extension a CTime time, etc.? No, there isn't. But what I will say is you'll notice that CTime is very careful to make sure that it takes the absolute least amount of its own time into account. Not that that necessarily helps you, but you can see that initially on entry it'll snap the get clock right there, and on begin it will actually snap the get clock again. So what it does is it takes the get clock as close to the end as possible on begin and as close to the beginning as possible on end, so that you're not counting more of CTime than you need to. Although CTime takes very little time to execute, so it doesn't really matter. Would it be possible to time compiling and linking separately? Certainly, if you do them separately. In Handmade Hero, we do them as one pass. So no, because there is no where you can't. Look, we are not able to get inside this C compiler to instrument it, right? But if you do it as two different parts, a compile and a thing, you can just wrap each part in a separate CTime begin and end, and then you can compile them separately, and then you can time them separately. If you have long build times, how do you find out what is causing it? That is a total other problem, right? If you have long build times and you can put CTime blocks around different things to find out which part is taking long, but once you get it down to a specific part, then it's just a question of why is my compiler slow, right? And at that point, really only the compiler vendor knows. You can do tests and try like turning things on and off and seeing what it is, but it's pretty tough. Byteflinger, are you essentially packing the run data into a file and updating it every run? Yeah, it just basically writes to the end of a file. Right? So it just writes a concatenation at the end of the file every time. That's all it does. Gingerbill, on Unix machines, mock absolute time is the best. Query performance counter is on Windows. There's no CR2 function with high precision timing. Yeah, but like I said, it doesn't need to be that high precision. So if clocks per second is generally 1,000 or higher, we could probably use that because it's just not that important to get, you know, millisecond or better timing. I just don't want 1 second granular because a lot of my builds take, you know, 0.9 seconds, 1.2 seconds, and I want to see that, right? Sunacron, have you tried standard chrono? Dude, anything that has std : in front of it, like, should generally be considered something you never ever want to use for any reason. Like, ever. Times 1,000. std just means bad code. Like, std stands for, like like, I don't know, probably like sucks to I don't know. I don't know how to change STD into something that means the code is awful, but I'll think of a good acronym for that, and that's what you should think of it as. STD just means really bad, don't call. Grumpy Giant 256. Clock is no good because it counts from when your process started. Oh, that's a good point. Duh. That's why I didn't use it. Yeah, I'm glad that Richard's got my back here. Yeah, right. You can't use clock because you need a time. You're running the program twice. You need it to be an actual time. So that's why I was calling time. Yeah, clock doesn't help you. Right. Sorry, I forgot about that. Clock can't help you because you're calling the program twice. So you need to know the actual time, like what time it is in the real world. And so that's why I had to use a time that was actually higher resolution, but that meant real world time, if that makes sense. Let me see here. Yeah. So you can see that I called time get time instead of clock or time for that reason. Yeah. Okay. Thank you for yeah. Duh. All right, so it looks like that is all the questions. So I think that's it. Like I said, this will be up in Handmade Hero if you want to grab it. I can also dump it in a paste bin on Twitter if anyone wants to grab it from there. But it should be widely disseminated at this point. So anyone who wants to keep track of their build times and make sure they actually know what they are and/or know how they evolve over the course of their project, this should basically do it for you. And at the other point is we will now have that built into Handmade Hero so we can also see. The other thing that it does that's kind of nice as well, you'll notice that it has that sort of thing too where you can see how often you build something, because in addition it always keeps track of how many times you built it. So when you look over time you can see, oh, I built like this many times and then I went down and didn't build much during this month or whatever. So that's kind of fun too. Columbian, if you use CTime during a daylight savings time shift, does it take into account the extra less hour? So that question is actually punted to the operating system, which maybe, you know, I wanted to keep this program simple, so I used the operating system to tell me what a day is. So you can kind of see on here that it does some stuff where it you know, assumes some information about how long a day takes and stuff like that, which is not particularly great. So not really. When it does print out dates, it does it correctly, but this could be improved. Like, probably what you would maybe do here is when you get day index, you could actually, like, this could be done better, I guess is what I'm saying. You could, I do file time to local file time here, which accounts, I believe, for daylight savings time correctly, assuming the operating system does, which, you know, they may have bugs as well. But I don't really do it in here. So this could probably stand to be improved. And what you would do there is you'd probably call this every time on day index, and then you'd use you would use some kind of a basis for that. So no. I mean, the answer is no at the moment. To think about that. So if I wanted to do that correctly, so you can see basically day index is just used, the only real reason is just to see roughly how many days there are, so it's not really used for anything particularly onerous. And obviously this part is correct, so when I say CTime CSV and I ask for one of these What did I call it? Oh wait, I'm in the wrong directory. So if I come in here and I want to see like CTime stats for, CSV for handmade.ctm. If I want to look at these are printed out. As you can see, they're roughly correct in terms of what time it is here, right? Those are when we did the build, 3:40 p.m. You can see that we probably did the build about 20 minutes ago, right? And that's what that is. So these are all correct as far as daylight savings time and all that sort of stuff, assuming that the operating system doesn't mess it up. What doesn't take into account those things properly is like if you do this, right? This thing, when it says 1 day per bucket, is actually using quanta of a day, which is not the same as routing that day to the actual calendar day. And if you wanted to make that happen, I think it would be relatively easy to do. I just have to think about exactly how you would want to do it. You'd probably want to do something like here you can see where I call first day at, last day at. I take these day indexes and I guess I did it correctly, it looks like. So if I just came in here, this would probably be sufficient. You just have to do this. You'd have to like truncate down to the closest day. So I'm just sort of talking aloud here because I haven't thought it through, but it would be something like this. First, you would go in and say, well, I've got a file time and a system time. Here's how I map those together. So I've done a file time to system time, and now I know, all of this information about the file, right? Let me get over here into this file. So now I know all this information. I know the year, I know the month, and I know the day, right? And what I can do now is say, well, let's get rid of the hour, the minute, and the second. We'll just nuke those, right? So we go in here and say, okay, so let's say the hour is 0 and the minute is 0. I believe these are 0 based. Let's find out. Yeah, these are 0 based, right? Oh no, they look 1 based. Are they? Well, let's see. No, 0 minute, second. So those would be 0 based. So I believe that would zero it out and put it at the base of the day. And then I would just need to go the other way round. So I'd need to now convert it back, if that makes sense. So then I would go and say, okay, now that I've gotten it routed to a physical day in my local time, whatever that is, then I can go ahead and say, all right, now we'll convert it back over. So we've got that system time. Oh, let's do it here. System time to file time, and then we can do local file time to file time, and that'll convert it back. So that would convert us back to some kind, an arbitrary actual point in time, and then we could get the information out of that, I think. So system time, file time, file time to file time. Does that make sense? So that would root it in one of our local days, map it back, and then I guess since we're subtracting, we don't really need to convert it from local to local anymore because we're just looking at some kind of an absolute piece of information here. So I think at that point you can just do this again. I think. So that's my guess. That's my guess. Whether that's right or not, I don't know. But that seems like it, right? So basically what I did here is I just said, like, okay, floor it to a particular day. And then actually look at the quad part of the file time and convert that to just however many days there are, so that they're based off of it, right? And maybe that's a little more correct. Probably it is. I don't know. That would take into account, things like leap seconds if you cared. I don't know that anyone does, but I think that's probably a little bit more correct. If that makes sense. Let me see here, though. Wait a minute. So this needs one more thing, which is the A64 U large integer part here with the quad part. That thing actually needs to come out of the file time. Yeah. Let's do that. Hold on a second. One more thing. That. Right, so after we do this conversion, our file time now has to be converted out to whatever we were going to do with the A64 here. So this part can stay the same. Instead of converting these this way, let's do this. These are actually going to come from these two pieces. Right? Why am I still building Handmade Hero? I have no idea. So that's all you would do there. And it's not going to change anything from our printout, right? But that might be more correct, if that makes sense. So I don't know, Kalimian, is that roughly... is that roughly what you were looking for? Because I think that's basically correct. Kalimian, indeed, that's what I was thinking. Okay, so hopefully now that's solved for you, if you care about those. And I can put here like note Casey to help keep things aligned with the user's local conception of day. We have the operating system floor to real local days here, right? All right, so I'm going to go ahead and wrap that up. And like I said, that'll be in the Handmade Hero repository now, so there you go. And I think, let me just double check to make sure we didn't break anything. We didn't. And so that's all in there. And I will push that out to everyone tomorrow. All right, that's it, folks. Thank you for joining me, and I hope that if you had any, if you had any builds that needed timing, that will no longer be the case after today. And I'll see you tomorrow for some Handmade Hero. Take it easy, everyone.